Hello everyone, this is Nawshad. I hope all of you are doing really well. Today we're going to learn about the HOG, histogram of oriented gradient. So firstly we need to think of a picture, like this is a picture, and we need to resize it. So if we resize it, it will going to be like this. If it's 1000 into 1000 previously, after resizing it, it will going to be like 500 into 500. So after resizing for a while, we will going to get a picture, this picture like this, 8 into 16. So it means it will going to, this picture will going to be going to have 8 pixels on this direction and 16 pixels on this direction. So altogether it will going to be 8 into 16. So if we took a single portion of this picture like this, so it will going to be like this, a picture with 8 into 8. The height and width will going to be 8 into 8. So in the question it will going to be given like this. A matrix will going to be given, a matrix, a single matrix like this. It will going to be like 5 into 5 or 3 into 3. So let's assume it as 5, 15, 25, 35, 25. I am taking the values randomly. Okay, so I will going to I took the values randomly, so it will going to be given in the question. So from this we need to calculate the histogram, or we need to draw the histogram. So firstly, for HOG we need to calculate two things. One is the gradient magnitude, another one is the gradient direction. So we need to calculate gradient magnitude and gradient direction for this single matrix. Okay, so after doing all the steps, we're going to have a single matrix like this for gradient magnitude, and also the similar single matrix for gradient direction. It will going to be look like this. Okay, so how we could calculate it? So firstly we need to take a value from this. So for 25 we need to calculate the gradient magnitude matrix and gradient direction matrix. So we will going to have it like this, gradient magnitude matrix. So it will going to be look like this, and gradient direction matrix. So from these two matrix we will going to be able to draw the histogram oriented gradient. Okay, so we have these two things. We need to calculate the values for this gradient magnitude and gradient direction. So if we took the value 25, firstly we need to take the value of x direction and y direction. So x direction means the difference between this value and this value, the value right and left of the specific pixel, like the difference, like 20, 35, the difference is 15. So x direction means 15, and y direction means the distance of the upper element and lower element, like 16, 60 and 10. So the difference is 50. Okay, so we got x direction and y direction for 25 value. Okay, so after this we need to calculate the gradient magnitude and gradient direction. For gradient magnitude, so we need to calculate it like this, the square root of x direction square, xd square plus yd square. So we have got the value for xd, means 15 square plus 50 square. So we got, what we have is 52.20. 52.20, we will going to consider it 52. Okay, so we got 52 as gradient magnitude. We cannot really take the decimal values, just generalize it like 52. Okay, for gradient magnitude we have got 52. So for 25 we got 52 as gradient magnitude. So in the similar pixel of gradient magnitude matrix we have 52. So we're going to write 52 here. Okay, so then we need to calculate the gradient direction. So for gradient direction we have the equation like tan inverse xd divided by yd, like the value from xd and yd will going to be like this, 15 divided by 50. So x direction value divided by y direction value. Okay, so then we have like tan inverse 50 divided by 15 divided by 50, we have 16.69. so 16.69, it's 17 approximately. Okay, so we have a value for gradient direction, so we will going to write 17 here. Okay, so for each values from the question we need to calculate a value for gradient magnitude and gradient direction like this. This is the way how we need to calculate the values for the question values, from the question values. Okay, so after completing all the steps we will going to get a matrix for gradient magnitude and a matrix for gradient direction. Okay, so I am calculating another value for better understanding. So how about a value which has no neighbors, like this 5? So if we need to calculate the same values for 5, so for 5 there is nothing on the left side. So if there is nothing on the left side, we're going to put a 0 on it. There is nothing on the upper side, so we're going to also put 0 on the upper side. So for now we have x direction values. So for this we have x direction values as 35 and 0. The difference between 35 and 0 is 35. So the x direction value will going to be 35. And how about this? The distance between 0 and 10, it will going to be like 10. So this is how we need to calculate the values which haven't a value in left, right, or upper side. Okay, so afterwards we will going to have something like this. So using this, we need to calculate the gradient magnitude and gradient direction following the equation previously I showed. So this is how we calculate the values for gradient magnitude matrix and gradient direction matrix. Now how we draw the histogram? So for drawing the histogram, we need to have we will going to have a value of this and this. So now I will only show the value for gradient magnitude like this. So after completing all the steps, we're going to have a matrix consisting 9 values like this, or gradient, direction. Similarly, after completing all the steps, we're going to have a matrix like this. Okay, so I'm randomly putting some values: 5, 10, 15, 20, 25, 30, 35, 60, 70, like this. Or here 60, 80, 20, 25, 18, 14, 35, 30, 60. Okay, so after completing like previously I have shown that how we could calculate this gradient magnitude and gradient direction. So from these two matrices we need to calculate the diagram. So for this diagram we will going to have values on the x-axis like this: 0, 20, 40, 60, 80, 100, 120, 140, 160, and lastly 180. So this will going to indicate the gradient direction, and the y direction will going to indicate the magnitude. Obviously it's basic gradient magnitude in the y direction. So for each pixel, like firstly we need to calculate a pixel like this. We're going to have 16 as gradient direction. 16 means this. This is where we can find the 16 as gradient direction value 16. So the corresponding value for 16 is 5. So we're going to calculate 5 here. Okay, then we got 80. So we're going to find 80 here. The corresponding value of 80 is 10. So here we will going to write 10. Then 20, like 20, we got 15. In 20 we got 15. Afterwards we got 25. So the corresponding value for 25 is 20. Like we cannot really find 25 here, no? So it's the middle. It's somewhere between this, like this. Somewhere between this we're going to find the 25. So like here we're going to have 30, then it will going to indicate 25. So the value for 25 is 20. So now we need to distribute the value to 20 and 40. The 20, this value, we need to distribute this value to 20 and 40. Like it's so closer to 20, that's why we will going to give more amount to the 20, lesser amount to the 40. So we will going to distribute 15 to 20 and 5 to 40. Okay, because it's closer to 20, so we gave bigger portion to the 20 and lesser portion to the 40. So when we can't find the exact amount in the direction, so we need to distribute the values. So if we need to talk about the 18, the corresponding value is 25. So 18 we will going to find 18 somewhere between like this, which is again closer to 20, not 0. So the corresponding value for 18 is 25. So we will going to give 20 to 20 and 5 to 0. Okay, 5 to 0. So that's what we need to do. If it's closer to somewhere, if it's closer to this portion, we're going to give much portion to this. If it's closer to this, we're going to give much portion to this. So this is how we will going to calculate the values. So after doing all of the steps, after completing all of the steps, we need to sum the values. If it's higher, like if it's like 100 and it's 19, it's 120. So the histogram will look like this. This is 120 after summation of all the values, and 100 will going to look like this, and 90 will going to look like this, which is lesser than 100. So this is how we need to complete the histogram. So now the last step is the vector. So we need to put the magnitudes on the vector, like we need to firstly draw a line, okay, the parallel line. So this is the point. So first we have the magnitude. Here the magnitude is 100, the magnitude is 90, the magnitude is 120. So for this 20 we have 100 magnitude, so the 20 degree is approximately like this. So we have this magnitude is 100. For 40 degree the magnitude is 19, so 40 degrees like this. So the magnitude is 100 firstly for 20. For 40 the magnitude is 19, so it will going to have lesser magnitude because it's 40 degree, and it's 20 degree which is 100 magnitude. For 60 the magnitude is 120, so it will going to be like this 60 degree, and the magnitude will going to be bigger than this two because it's 120. So this is how we calculate the vectors, like this. So this is the way how we calculate the HOG, histogram oriented gradient.